So good morning and good afternoon. I would like to welcome you all in today's webinar entitled Lesson Learned from the First Concrete Fix Rockfilled Dam in Nepal, which is jointly organized by IHR and Dynamic Solution. I am Naresh Suwal, a PhD scholar at Louisiana State University. So before start, I would like to first introduce IHR and Dynamic Solution. Institute for Integrated Hydro Environment Research, which is IHR, was established in 2021, and IHR is a non-profit research for development organization based in Nepal. It aims to stimulate generation of knowledge and its application to solve critical problems in the field of water resource and environment. And our research activity follow a holistic and integrated approach to extend understanding of regional and global issues. Furthermore, we specialize in area ranging from fluvial hydraulics to sustainable water resource development and management through eco-hydraulics, hydroinformatics, and water-induced disaster, including effect of climate change. And Dynamic Solution was established in July 2022 under the Government of Nepal Company Act 2063, and it focuses on transferring knowledge and technology within the civil engineering industry to engineer and export both in Nepal and internationally. It provides high quality consultancy services using the latest technology at affordable costs. And additionally, Dynamic Solution aims to empower young engineers through research and development and educational training services. So as part of our commitment to knowledge dissemination and capacity building, we organize training programs and webinar related to water resource. And this event is also a continuation of our ongoing webinar series. It's my pleasure to introduce our moderator, Mr. Kamal Prasad Pandey, a doctoral student at ETS Zurich. And I would like to give some introduction about Kamal. So he earned his bachelor degree in civil engineering from Pulchak campus, and he did his master in water conservation and hydropower engineering from Hawaii University. Mr. Pandey has taught water-related subject and gained 3 years of professional experience as a hydraulic moderator and eco-hydraulics researcher at Hydrolab, Nepal, with expertise in physical hydraulic modeling for high dam projects like the Dukosi Dam. He brings valuable insight into dam operation, safety, and eco-hydraulics, and he has contributed to numerous projects and published many papers in water-related research. So, Mr. Kamal, the floor is yours. Thank you.
Thank you, Naresh, for the introduction. And again, warm welcome to you all once again, and thank you for being here. So I am Kamal Prasad Pandey, today's moderator of the webcast. And today's webcast session is on lesson learned from the first concrete-faced Rockfilled Dam of Nepal, which is named as Dhap Dam, which is organized by the Institute for Integrated Hydro Environment Research, as mentioned by Naresh. And this event is a platform to explore the multifaceted aspect of this groundbreaking project, which is of immense significance not only to the river basin but also for the future of the water resource development and management in Nepal. So if we talk about this project, it is constructed within the Sivapuri Nagarjun National Park, which is a site of ecological importance as well as the spiritual importance. So this dam is kind of a mix, which is a kind of example that a delicate balance between the development and sustainability can be achieved through the means of suitable engineering. So moreover, this is also the first instance of CFRD in Nepal. So this project also has set a new benchmark in dam engineering, offering a valuable insight into the modern construction method and then and their applicability for Nepal's diverse and challenging topography. So we are privileged to have with us today our distinguished presenter, Mr. Nishchal Chhatkuli, former chief project engineer for the Bagmati River Basin Improvement Project, and he has extensive experience and leadership quality. He has been instrumental in navigating the technical, environmental, and policy challenges that were related to the Dhap Dam construction. Further, I would like to introduce him as an esteemed water resource and irrigation expert with over a decade of professional experience in the field. He currently serves as a senior divisional engineer and project chief at Paragna and Barkapat Irrigation Project, Lamai Dang, under the Department of Water Resources and Irrigation. So, talking about his academic achievement, he holds a bachelor's degree in civil engineering from Pokhara University and Masters of Technology in Water Resource Development from IIT Roorkee, which is one of the premier institutions in the field, known across the Asia region and worldwide. So, his extensive list of professional experience include works in many national importance projects such as Rani Jamana Kularia Irrigation Development Subdivision, Mugu, Bagmati River Basin Improvement Project. So, in summary, his expertise lies in planning, design, and supervision of critical water resource infrastructure in Nepal. So, we are truly honored to have him share his valuable insight with us today. So, I want to give applause to his availability and making his presentation known to other enthusiasts in the field. Now, I would like to head to our next session of our program, which will be the presentation by our expert, Mr. Nishchal. And then it will be followed by a panel discussion after the presentation. So, to our participants here, I would like to inform that during the discussion session, you can post your question in the chat of the Zoom, and then we will take the questions from the participants while we are continuing with the discussion with the panelists. Then the panelists and the experts, they will answer to your questions. And this will be followed by the conclusion and closing remarks of the today's webcast. And also after that, I think we'll shortly send you a Google form link stating what were your views regarding the webcast session and what are the further improvement that can be made in the future, so that it can be made into more lively discussion or more technical or more generalized discussion. So I would like to hand over the floor to Mr. Nishchal so that he can start presenting his views on the lesson learned from the first CFRD of Nepal, the Dhap Dam. Thank you.
Namaste and good morning. Thank you, sir. Are you hearing me?
Yes, sir, we can hear you.
Thank you, sir. As the moderator has already been introduced about me and the topic of this presentation, directly I would like to proceed my presentation. Before starting my presentation, I want to say something that during my stay in Bagmati River Basin Improvement Project, irrigation unit, project implementation irrigation unit, which was responsible for construction of Dhap Dam, design and build of Dhap Dam, and preparation of the Nagmati Dam. My involvement in that project was from the client side, and the dam was constructed, constructed by the panel of experts, engineers, and donors, experts from donor side. Their valuable contribution is always appreciable. Being a involvement, being a participants from the client side, so I would like to highlight the experience and the lesson learned from the Dhap Dam in general way, because I have already mentioned that we can seriously discuss in every topic in a specific way. So today I will only highlight the experience and the lesson learned in general way. These are the outline of my presentation. First of all, I would like to highlight the overview of CFRD. and then I will introduce about the Dhap Dam. Then I will enter into the main topic of this session, the lesson learned from the Dhap Dam. Under this topic, I will be highlighting in two aspects. One is technical aspect, and other is contractual aspect. And at
Sorry to
last,
interrupt, sir. Okay. Are you already on second page of the presentation? Because we are just seeing your first page. Sorry to interrupt you.
yeah. Is it visible?
Not yet. I think you can close that session and then restart the presentation mode. And I think it should be okay.
Yeah, it is in the presentation mode. I'm in the presentation mode. I'll try again. Is it visible?
Yeah.
Yeah.
Now, is it visible?
Yes.
Yeah.
Yes.
Okay.
That's good.
Oh, okay. Okay. The first is the overview of CFRD. I have already mentioned. And then introduction of Dhap Dam. And I'll enter in the main topic of this presentation, lesson learned from the Dhap Dam. Under this topic, I'll be discussing about on two aspects, mainly on two aspects. One is technical aspect and another is contractual aspect. And at
Hello.
I think Mr. Nishchal is having technical issue with the Zoom. I think he will rejoin shortly. Mr. Rakesh, can you please handle this?
Yeah, I think he has joined. Yes. And in the meantime, we can welcome our guest. Come on.
Okay. I think during his absence, I can briefly introduce to our panelist of the today's discussion. So the first panelist would be the Mr. Naresh Suwal himself. So he's also the prime moderator of the session and also the panelist for our today's discussion. So he holds a PhD. He is currently doing a PhD in Louisiana State University, and his research focused on applying machine learning and deep learning to geohealth. And he has extensive experience in water resource management, particularly in optimization and hydrological modeling. So he has also published several articles in peer-reviewed journal, most related to the multi-objective optimization of the reservoir and scheduling. And so his expertise would be useful in discussing the problem related with the multi-objective optimization of the reservoir, such as the Dhap Dam. So the second panelist for today's discussion is Mr. Khem Prasad Bhattrai. He is also a PhD candidate at Colorado State University, and he specialized in the numerical study of canonical environmental flows. His current research focus on the numerical investigation of multiple gravity current, exploring their dynamics and interaction. He also brings a wealth of experience in small to medium scale hydropower design, which he used to do in Nepal, and transient analysis, flow 3D simulation, optimization, and neural networks. So his expertise also bridges the theoretical insight and practical application, driving his commitment to advancing the fluid mechanics and developing the innovations solution for the water resource challenges. So his expertise would be useful in discussing various aspect that is related to the design of the hydraulic structures, as well as use of the numerical method and hydrological modeling to optimize the solutions.
Kamal sir, can we continue with the Nishchal sir? Because Nishchal sir is, I think, he has.
Okay. So let's welcome back to Nishchal sir, and I would like to hand over the screen to Nishchal sir. Mr. Sir,
This is
you
a
may continue.
you can
Okay.
make your screen full in presentation mode because it is not. I
Yeah.
think
It is visible.
yeah, it is
It is okay.
visible, but you have to click on the presentation mode.
Yeah, I have already clicked. Now, is it visible?
Yeah,
Uh,
it is visible.
No. Presentation mode is not visible. Only this.
so,
Okay.
Michelle sir, I would recommend you that you don't share the presentation while doing the sharing. You just share the whole screen of your laptop,
Yeah,
and then the presentation mode should be visible when you click on the presentation mode. But if you are sharing only presentation, it may not be visible. So you can try by sharing the whole screen of your laptop.
Okay.
yeah.
Maybe you can swap the presenter, and if you have two screen, you can swap the screen.
Mm,
Hmm. Yeah, just click on that
yeah.
PPT.
Is it visible?
Yeah, yeah, it is visible. So just open that PPT and then click on the presentation mode. I think
Okay.
No, PPT is not visible. I think you opened this PPT, but
Yeah, we are seeing
Okay.
the
I'll try.
different screen, I think.
Parthi sir, can you? Okay. So let's
Okay.
continue.
Okay. This is the overview of CFRD. CFRD mainly consists of concrete slab supported and stabilized by underlying rock-filled materials, which are uh, in the form of different size and the gradation of the rock-filled materials increase from inner to outer side. And whole dam body is connected with the plinth slab, and there is provision of perimeter joint between dam body and the plinth slab. The concept of CFRD was originated during California gold rush in 1860s, and it's a quite competitive alternate to concrete dam, and it has significant economic advantage of using local materials. For example, in the case of Dhap Dam, we have used more than 80% local materials, and CFRD has excellent adaptability to topographical and geological condition. And obviously, this dam is seismic friendly, and this type of dam can be constructed in alluvial as well as rock bed. For example, we have built Dhap Dam over whereas the Dudkosi Dam is proposed in alluvial bed. Uh, this is just the overview of CFRD, which is being constructed across the old, having the height more than 200 meter. This is just the example I have shared. As you can see, 230-meter high CFRD was built in China, which was started in 2003 and completed in 2008. Similarly, another dam having 2000-meter, 19-meter height was built in China. And similarly, another 2009-meter in Mexico, 2005-meter in Malaysia, and 202-meter in Brazil. This is just the example you can find in the internet also. Uh, Now coming to Bagmati River, as you can see, the cultural and economic significance of the Bagmati River from this photograph also will be cleared. And this river is, as we know, this river is completely considered as a holy river used for the cultural and ritual ceremony. manage. Uh, but sadly, the condition of river in Areghat during dry season is very bad. You can see from this figure. So to overcome these issues, various type of effort that has been made by the government of Nepal and other agencies. The concept of the Dhap Dam was originated uh, from long time. Basically, Japanese water agencies has carried out different studies for the water resource management of Kathmandu Valley. Based on that, Bagmati Action Plan was prepared and issued by government of Nepal in 2009, and the time horizon for this plan was 2009 to 14. Now it has been updated from 2000, I think from 2022 to 2024. It is under the approval process from the cabinet. Based on Bagmati Action Plan, pre-feasibility study of the Dhap Dam was carried out by Danish Hydrology Institute in 2013. Based on that study, design and build of Dhap Dam was started in 2015 under the BRBIP, Bagmati River Basin Improvement Project, with loan assistance from ADB. During the course of this construction, also, government of Nepal has issued a water resource policy, which has clearly mentioned about the augmentation of dry season flow in the river through construction of the reservoir projects. This is just the summary of Bagmati Action Plan 2009. The vision is clean, green, and healthy river system that is full of life and valued by all. Under this action plan, uh, as you can see, the in activity 1 is to undertake various measures to protect and enhance water resources and increase water discharge into a river, like developing reservoirs in Sivapuri National Park. Based on that, Dhap Dam was started. Construction of Dhap Dam was started. Uh, and another main objective of Dhap Dam is to enhance the water resource and increase water discharge into the Bagmati River in dry season, and maintain and enhance the river water quality. And other important objective was during its concept, it was considered as the future backup for providing safe drinking water in Kathmandu Valley. Immediately after completion of the dam and reservoir filling, we have started water barter between Kathmandu Upateka Khanipani Limited and Bagmati River Basin Improvement Project, HPCI DBC. During first water year, we have released water from Dhap Dam during the rainy season, because as we know, the devastating flood and debris flow in Melamchi River, the tunnel will not be able to deliver water in that period, and the scarcity of water in Kathmandu Valley is obvious. So to address this problem, we have make an agreement for the for to, as a water barter agreement between KUKL and HPCI DVC, and 32.112 crore liter water was provided to KUKL and in rainy season, and during dry season, because in dry season there is uh, sufficient water in Melamsi River, and KUKL has provided 32.21 crore liter water to reimburse the water that has been released from Dhap Dam to the KUKL. This is the scope of Dhap Dam. It consists mainly 24-meter high concrete face Rockfilled dam, and the storage volume was initially 0.85 MCM. But later on, after completion of the dam, there is sufficient increase in volume of the reservoir. It's became 1.42 MCM. And there was one number of saddle dam, since the dam was located in ridge line between Bagmati Basin and Indravati Basin. Initially, in pre-feasibility study, one saddle dam was identified, but later on, while finalization of the topographical survey by designers team from contractor side, another additional two saddle dam were identified and built by the contractor, and we're having 21-kilometer access road from Sundarijal to Dhap Dam. And the design philosophy of CFRD is there is no danger of overtopping, and seepage line is well within downstream phase so that horizontal piping may not occur. The upstream and downstream slope are flat enough to be stable with the materials used for the construction of embankment for all conditions during construction, operation, and sudden drawdown. For example, in the case of Dhap Dam, we have provided 1:1.7 side slope, both in upstream and downstream, where ICOLD has recommended only 1:1.3 slope for this type of dam, but for the safety purpose, we have provided 1:1.7 side slope. The shear stress induced in the foundation is less than the shear strength of the foundation materials. For this purpose, the embankment slope should be sufficiently flat. The upstream and downstream faces are properly protected against wave condition and the action of rainwater respectively. For example, we have provided parapet wall over Dhap Dam, which will retain the wave back to reservoir rather than allowing it for overtopping. This is the contract information about the Dhap Dam. It is design and build contract. The location of Dhap Dam is lies Gokarneswar 1, Kathmandu, and it is entirely lies in Sivapuri National Park, Sivapuri Nagarjun National Park. The client was Department of Irrigation, Water Resource and Irrigation, and the contractor was Gonjao Lama Raman JV, and around 51 crore was the contract amount, including VAT. This is the main feature of the Dhap Dam. Dam height is 24 meter. Top length is 174.7 meter. Crest elevation is 2090.14 from mean sea level, whereas upstream slope and downstream slope, as I have already mentioned, crest width is 8 meter. Thickness of face slab is 300 mm, and dam volume is around 51,000 meter cube, but later on, due to increase in dam length, the volume has increased, and normal water level is 2087.14, and freeboard is 3 meter. This is the typical section of CFRD, where you can see the face slab in water phase. This is the face slab. Below the face slab, we have provided 2B materials, which is 75 mm down materials. Below 2B and over the ground surface, we can see 3A materials, which is 75 to 150 mm size materials. Below that, we have provided 3B materials, which is 150 to 300 mm in size. Below that, we have provided 3C material, which has 400 to 450 mm in size, and at downstream phase, we have provided free size boulder having 600 mm above in size. And similarly, you can see the plinth level here. This is the plinth level, and this is the ground profile. The main concept of CFRD is we need to have a competent bed to lay the plain slab. As you can see here, there is deep excavation, and as you go towards downstream, you can see there is slightly decrease in excavation. Uh, so we can compromise the grade of rock while going downstream, but at the upstream where we are going to lay plain slab, the rock should be competent uh, in strength. And these are the other materials, 1A, 1B, as you can see, 2A. These material are laid over the plain slab, and these materials will prevent the seepage from the minor cracks in the plain slab, and also reduce the water pressure in the plain slab. These are the different phases which has been proposed during the construction. As you can see, from phase 1 to phase 7th. Seventh, because to optimize the resources and to materialize the design in optimum way, this phase was developed, and to ease the construction also. These are the different activities that has been carried out in under different phase. You can see from phase 1 to phase 9. So I'm not going into detail. Now I'm coming to the main topic of this presentation. Under this lesson learned from Dhap Dam, under this topic, I'm in this slide I'm going to highlight about the technical aspect. In this aspect, the crucial activities that has been carried out are the foundation treatment, which is called as grouting, similarly face slab casting, laying of joint networks, and instrumentation. Now coming to grouting, we are having two type of grouting over there. One is consolidation grouting, and another is the curtain grouting. Under consolidation grouting is grouting mainly deals with the bulk property of the rock, and up to 5 meter depth we have applied consolidation grout in 2 rows, and hole spacing varies from 8 to 2 meters. Similarly, the curtain grouting deals with the foundation seepage to limit the seepage within 3 lumen, which was our employer's requirement. And we have carried out curtain grouting up to 15 meter in single row, and based on the geological profile, we have applied curtain grouting in primary, secondary, and quaternary holes, which is spaced between 8.4 to 1 and 0.2, like this order, following this order. And grout pressure was ranged 5 bar for 0 to 5 meter, 10 bar for 5 to 10 meter, and 15 bar for 10 to 15 meter. And the stopping criteria was based on the volume, 300 kg for 0 to 5 meter and 200 kg for 5 to 15 meter. And the grouting intensity number was 1500. 1500. And Lucent test was carried out to confirm the permeability within the range. This is the envelope developed for the grouting, especially for curtain grouting. As you can see, grout volume in x-axis and the applied pressure in the y-axis. This envelope shows the characteristics of the rock, and as you can see here, this shows the rock having less fissures, where this side shows the rock having more fissures. In this area, we will control the grout take by volume, where in this area we will control the grout take by pressure. Uh, this is the prediction of the grout performance. This research was done by Anup Lamisani. At that time, he was the master's MSc student in geotechnical engineering from Pulso campus. He has carried out his research in Dhap Dam entitled Seepage Characteristics of Dhap Dam, and he has predicted the grout performance in before grouting and after grouting, in basically focusing in three regions. Chain is 40, 75, and 145. This was the actual uh, grouting seepage before grouting, and this is the seepage predicted seepage after grouting. And this graph was also developed by Anup. I would like to thank him. Now he's in USA and doing his PhD. Here you can see the profile of Lucent value. As you can see, we are having a list Lucent value before grouting in right bank and mid section, whereas we have encountered maximum Lucent value in left bank and mid section. We have recorded maximum Lucent up to 50 in the left bank. Later on, this graph was developed by our office based on the real seepage measurement in the downstream of the Venus, which has been installed by the contractor at the toe of the dam. This seepage data was measured manually by PIU team, our team, and as you can see, the graph shows there is minimum seepage in the month of March. This is the real seepage. As you can see, there is increment in seepage before and after this dry season, because this area and this area there is contribution of runoff from the vicinity of the dam and dam body also, and there is no runoff during March. And this is the real seepage, and real seepage is around 1 lps, which is more safe as suggested by the experts. Now coming to the various problems that has been encountered and the measures applied to resolve that problems during grouting. First problem is leakage of grout material outside the plinth and interface of the rock 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 bed and the plinth and the nearby hole. The main cause of this problem is removal of overburden, uh, because due to difficulties in excavation from machine, the overburden between the uh, border of the plinth line and existing ground was slightly removed. From that portion, the grout was exit out, and initially we have drilled all hole grout hole at a single time. This was also the main cause for this problem, and the effect was wastage of grout material, because to achieve the desired illusion, we couldn't compromise in pressure and volume, so lots of material was wastage, and required uh, grouting intensity number was not achieved. And the main measures used for the resolution was the overburden applied outside the plinth slab. We have applied we have laid so many concrete we have concreting in the open excavated portions and grouting is applied in primary, secondary, tertiary and quaternary hole. We have reduced the spacing of grouting from 8 meter to 0.5 meter. Similarly, coming to next problem, the problem was the grout material not injected smoothly. The main cause behind this problem was use of centrifugal form, use of percussion drilling, air flushing, fineness of cement, lack of colloidal mixer, encounter of sand zone in left abutment, lack of export for implementation of the grouting activities. Finally, desired illusion was not achieved due to this problem. And as a resolution, we used water flushing instead of air flushing, and we used colloidal mixer uh, uh, instead of normal mixer, and we used piston pump with digital flow meter, and we increased fineness of cement. Ultra fine cement was used. We used ultra fine cement having 8800 blend value in left bank, and we used rotary drilling, and we have revisited the mixed design of the grout materials. As I have already mentioned in my slide, this is the open excavated portion from where grout material was exited. To overcome this problem, we have applied concrete, pour the concrete in this area, and this is the rotary drilling. This is the percussion drilling, which was initially used. Later on, this was replaced by the rotary drilling, and uh, this is the concreting. This shows the concreting in open excavated portion, and this is the colloidal mixer. This is the core sample taken out from the grout hole, and this is also the piston pump which is being used with flow meter, and this figure shows the cotton grouting. Now coming to face slab casting, the grade of concrete was B25, which is equivalent to M31.5 in it is British standard, having cylindrical strength, and admixture used was super plasticizer and air entrained agent, and mixing was done by plant, batching plant having 25 meter cube per hour, and transportation one was done by transit mixer, and chute was used for laying the concrete, and we used slip form for 9 panel out of 12 panel, and we have fabricated the slip form locally, and I think this type of slip form was the first slip form which is being used in the inclined surface in Nepal. And the conventional formwork was used for 3 panel and other starter slab. Starter slab is the slab which was casted in the irregular portion of the dam, because the dam was constructed in the river valley, which is not regular. For the regular portion, we have used slip form, and for another portion, we have used conventional formwork by constructing the starter slab. And I have already told slip form was locally fabricated, and Mr. Engineer Rajkumar Cholagai now he's in Thapatali campus, I think, and doing his PhD also. His input was really appreciable, and he has fabricated this slip form, and the velocity of winds to pull the slip form was 2 meter per hour. Now coming to the problem encounter and the measure applied during the face slab casting. During face slab casting, the main problem encounter was unequal movement of the slip form. Uh, the main cause behind this problem is use of single winch and inappropriate alignment of the rail. And the effect was reduction in the efficiency of the slip form significantly. For the resolution, later on we used double winch, and uh, uh, the rail was made proper in alignment. And another problem is uplifting of slip form. The main cause behind this problem is insufficient weight of the slip form itself, because initially we have designed the slip form uh, uh, having lightweight in order to optimize the weight of metal. And the effect of this due to this problem was the surface undulation in concrete face, and reduce the efficiency of slip form itself. And as a resolution, we have added dead load in the slip form, as you can see the concrete block over here. And we have clamped the rail and slip form, and uh, uh, the movement of the slip form was slightly modified. Initially, the slip form was designed for the continuous movement, which was in 2 meter, uh, having 2 meter per second velocity, which was synchronized with the initial setting time of the concrete. Later on, due to this problem and due to fall in temperature, uh, uh, due to low temperature, it was very difficult to attain the initial setting time in so we have later on we have modified the slip form movement from intermittent to intermittent movement. First, we have applied concreting in 2 meter section, whole section of the slip form, and then only the slip form was pulled, uh, and you can see this is the winch, double winch, one winch. You can see one winch here and another winch in another side, and this is the problem encounter. As you can see, there is a distortion in the shape of the concrete, and this is the working platform of slip form, where you can see the labor workers and the dead load applied in the slip form. This is the face slab, where we can see the concrete casting through the slip form. And these are the order in which face slab were casted. Now coming to installation of joint network, in Dhap Dam we are having different type of joint. One is perimeter joint, another is vertical joint, and last is horizontal joint. Altogether we are having 733-meter joint network. The perimeter joint was provided between, as I have already mentioned in my initial slide also, the perimeter joint was uh, constructed between the dam body and the foundation plinth slab, and the vertical joint was constructed between two panel face slab panel, and horizontal joint was provided between the face slab and the parapet. As I have already mentioned, the function of the parapet was to return back the water wave into the reservoir, rather than allowing it into the in rather than allowing the overtopping. This is the different photograph. These are the different photographs during the joint network construction, where you can see this is the now coming to this slide. I would like to highlight about the feature of the joint. This is the typical example for the perimeter joint. This is the starter slab, and this is face slab. Uh, uh, this where you can see at the bottom sand asphalt mixer in face slab portion, and directly will embed the copper water stopper into the starter slab. And over this you can see the neoprene filler between W shape. This is W shape water stopper, where in the middle section we have inserted neoprene as a cushion during the movement of a joint. Over this we have also inserted polyurethane foam, and above this we have also provisioned bitumen fiber, and above the fiber we have applied graded sand mixer, and the sand mixer was covered by the rubber band, and rubber band was fixed into the starter slab and the face slab by angle. uh, with this now I want to highlight about the different activities during joint network construction. As you can see, the fixation of the angle to and the rubber band. This is the completed part of the joint, and this is joint construction phase. This is sand asphalt laying, and this is the W shape copper water stopper, and different stopper was connected joint each other by brazing technology. And the thickness of the copper water stopper was 1 mm. As suggested by iCode, we can use 0.8 mm thickness, but for this height of dam, but we have used 1 mm thickness copper water stopper. And the main problem encountered during joint laying was the bending of copper water stopper to match with the plinth profile, because plinth profile was aligned according to the shape of the valley, and there is a curvature in plinth profile. The effect of due to this problem was the gap formed in the interface of sand asphalt and copper water stopper, and intrusion of concrete from this gap. And the measures applied for the resolution was, we have pressed the copper water stopper applying the compressive load, and the gap was fulfilled. And since the copper water stopper is ductile material, and we were able to fix this problem. Now coming to instrumentation, we are having different type of instrumentation. Basically, there is joint meter, a different type of joint meter, perimeter joint meter 4 numbers, and joint meter 4 numbers, and settlement point. We are having 6 number of settlement point in main dam, and 6 in each saddle dam, and we are having 2 strong motion axiogram. One was installed in the dam top dam crest, and another was installed in the vicinity of the reservoir. And we are having standpipe piezometer, 2 in main dam and 1 per saddle dam. And we are having also digital water level, 1 digital water level and 1 water level gauge. And we have installed V-notch for the seepage measurement from the foundation, which was installed in 2 of the dam. And we are having also a rectangular weir with RLS, which was made at the downstream of the reservoir for the measurement of the spill as well as the release. And we are also having 1 automatic weather station, which was set up in the vicinity of the reservoir. And beside from this, we have installed different RLS below Nagmati dam axis, Nagmati intake. There is diversion canal from Nagmati to Bagmati river in order to increase the power capacity of the Sundarijal hydropower. And we are also using this channel to release to convey the water release from Dhap Dam to Areghat because in Sundarijal area there are so many diversion that has been constructed by the local community for the drinking water, irrigation and other purposes. And we are also having dam break alarming system. Initially the data acquisition system has already been completed, and we need to have human interference between data acquisition and information dissemination. Recently, I'm not properly updated about these activities. I think these activities is in the progress. In I think almost in the final stage. Now coming to the different problem related to instrumentation as are releasing constant discharge with respect to declining head because uh, uh, recent now we are having just the hunger whale valve. In this valve we control the flow discharge manually, and problem is installation probable solution is installation of flow meter with actuator. uh, we have so many time we have discussed with ADB and other experts, but for this small dam this sophisticated instrument is not required. They suggested us it is not required for this such small dam. And another problem is lightning. Because of lightning there is frequent damage in instrumentation. Probable solution is installation of source protection devices. And another problem is lack of instrumentation engineer, because in government entity such manpower is not provisioned. So deputation of instrumentation engineer through contract is essential. And another problem is data communication and transmission due to lack of internet facility, because the dam is totally lies in the park area and there is not reliable network of uh, telephone and internet facility. To solve this problem, we are discussing with Nepal Telecom for the installation of NTC tower over there. Now, I have concluded the technical aspect, and coming to contextual aspects. This is the pros and cons of design build contract, where the pros are optimization of resources. Client gets to choose qualified contractor, enhance the capacity of local employer and contractor, reduce the chances of variation, less disputes, reduce the project cost and construction time, and the team working collaboratively towards a common goal. Cost of design is comparatively less than the individual design, whereas the cons are design will be less creative, because the contractor will try to optimize the resources, and he'll try the less input for the design, because every private sector want to make profit. So with using less resources, since there is less resources used for the design, then creative design will not be achieved. A lack of competitive bidding, because we are having very competitive contract, competitive contractor for this type of contract. And employers and contractor are less familiar, because we have faced so many problems during construction of this dam, and we have taken output from the different exports across the world, and we have to depend heavily on design build contractor, and there is lack of standard bidding document for this type of contract, and difficult to resolve the disputes, because during construction of Dhap Dam, still we are having a couple of disputes which is being under uh, the process of resolution from the Supreme Court. Uh, The main problem faced during contact management are the site position, variation, price adjustment, changes of designer and engineer, because during the course of contact management, there was replacement of the engineer, which is very difficult for us to implement the contract. And the cause was main cause behind this problem was the delay in approval of tree cutting, ambiguity in contact document, and ad hoc decision from the oversighting agencies. And the effect was time and cost overrun and dispute arises. Measure applied for this resolution, for the resolution was UOT granted and PA price adjustment was applied as per contract. And the dispute resolution mechanism was functional during the contract management phase. Now I'm coming to way forward. For the technical aspect, following are the way forward from our side based on our experience and lesson learned from the Dhap Dam. And one is use of GIN plant for grouting. GIN plant is very sophisticated plant which is being used for the profit grouting, and the main function of this plant is to optimize the grout volume, and the efficiency of the grouting will be achieved by using this plant. And use of ready-made slip form, use of concrete form, use of geotechnical sufficient geotechnical investigation, because this investigation make us easy for the optimization of grouting and other foundation treatment and design also. And proper topographical survey, because in the park area where we were not able to conduct proper topographical survey in feasibility study. Due to that reason, later on while designing the dam, another two saddle dam were encountered, and contractor has also built that saddle dam, but that issue was under dispute and process of resolution. And another uh, point is seepage and settlement data collection during the construction phase, because the main theme of the CFRD is we need to have a proper FEM, proper settlement analysis before construction of the dam during design phase. Based on that, we need to find out the probable settlement, and the 75 of the settlements should be done, should be there during the construction, and the construction, the time taken for that settlement, based on time taken for that settlement, the construction period should be decided. And now coming to contractual aspect, we need to have we need to prepare risk matrix and analyze this, and prepare the employees requirement precisely. Presence of lead partner in the case of joint venture, because Dhap Dam was also joint venture between the Nepalese contractor and the Chinese contractor, but we were not able to have the Chinese contractor on board during the construction. So it is very difficult for the national contractor to carry out the whole work as per the design. And capacity building of the national contractor on design and build type of contract, because we are having very less knowledge about this type of contract. And presence of designer during construction, testing and commissioning and operation, because the designer is not readily available in our country, so we need to hire the international expert, and it was very difficult for the Dhap Dam also to match the time between the export and contractor schedules. And we need to increase DLP up to 5 year, because 1 year DLP is not DNP is not sufficient. in the Dhap Dam also, we are trying to conduct the test after completion, but due to problem in various instrumentation and like other things, it is difficult to conduct this test within 1 year DLP. So if we have sufficient DLP, then we can conduct the testing properly. Now coming to policy and institutional aspect, we need to have integrated water resource act. Due to lack of this act, we are having so many different opinion from the different sectoral agency. If you see the case of Nangmati also, we are having different type of opening from different type of agencies. If we have provision for integrated planning, then such type of ambiguity will be minimized, and there will be collaboratively working culture will be developed. And we need to have dam safety policy and act. As we know, in our neighbor country India, the dam safety act has already been issued by the government. Similarly, we need to have dam safety department, which is responsible for the planning, constructing, operation and maintenance of the dam, and the sectoral agency will be responsible for their one network based on the integrated planning. And we need to have we need to build the capacity, and we need to have a standard bidding document for design and build and EPC contracts. And finally, we need to have fast track procurement act. Now I'm going to share some photographs in chronological order. This was the existing reservoir, where you can see small dam which is being constructed by the EC mode, basically for the to provide drinking water for wildlife. And this is stone foundation stone laying photographs of Dhap Dam. This photograph was taken during the foundation, and you can see the progress of the dam. And this is 3A materials, this is 2B materials, and you can see the different stage of the construction. And this is the plain slab, this is temporary diversion. This is permanent release, permanent outlet, and where you can see the casting of foam. This is the spillway, and these are the you can see the different face slab panels, and you can see also the joint networks, as I have already mentioned in my previous slide. Here you can see the final shape for the first CFRD of Nepal. These are various instrument. This is standpipe piezometer. This is the Venus being installed at downstream of the dam, and this is settlement point, and this is survey monuments. This is the RLS being installed at downstream of the spillway for the measurement of spill and release. This is the data logger covered by the CGI sheet, and this is the strong motion accelerogram, and this is automatic weather station. Besides from instrumentation, we have also built the other structures focusing the visitors. This is the viewpoint from where 70% of the reservoir area is visible, and this is the vertical joint meter installed between the two face slab panel, you can see here. And these guys are from Nepali army. They are doing Gotakhor training over here. And this is the operation and maintenance building. One is operation and maintenance building, and another is the park office. And this is the security post. And Nepali army will be responsible for the security of Dhap Dam. And you can see the impact of Dhap Dam in terms of tourism. Here you can see the 11 years data that has been published by Department of National Park and Wildlife Conservation. Here you can see after operation of Dhap Dam, after reservoir filling, there is uh, exponential the increase in the number of visitors and the revenue also. Initially, before filling the reservoir, the revenue was below 1 crore. After filling the reservoir, the revenue grows up to above 5 crore. And this is the dream before constructing the Dhap Dam. We have model such type of structure. This is our imagination, and this was the reality. Uh, for the further information, you can also visit the Dhap Dam website, from where you can get further information. Uh, with this, I have I'd like to conclude my presentation, and will be with you. And thank you, and over to you, sir.
Okay, thank you, Mr. Nishchal. That was quite an amazing presentation. We learned a lot from your presentation, and thank you for uh, explaining in detail the technical aspect as well as the retaining issues related to the contractual agreement in such a big project. And it is one of the first and unique kind of the project in Nepal. So now I will provide you the summary of the presentation, and then I will open the floor for the panel discussion. I see we have already got some questions from the audiences. Then we'll shortly take those questions one by one and forward it to the experts. So with this presentation, the summary is as follows. The CFRD has advantage on different topographical settings as mentioned by the presenter. And in the particular case of the Dhap Dam, there has been multi-level organization involvement. And one of the peculiar issue is related to the preservation of the cultural heritage, which is the sufficient amount of the flow in the Bagmati River. And also, since the dam is built on the conservation area, it has got a huge environmental significance. And I found it quite amazing that there is a barter system of water between different agencies, which I will come later and ask to Mr. Nishchal, explaining what is the barter system between the KUKL and the Dhap Dam Authority. And it was quite interesting to see the technical details of the dams and different construction phases plan, how they are scheduled, and what are constructed in first and what are the different phases of the constructions. And also it's quite interesting to see, like even though you have a concrete plan and all the advanced engineering in today's generation, yet you will still face some of the challenge. And Mr. Nishchal described this challenge related to the grouting, face slab concreting, as well as the joint construction, and how you are able to solve this problem during the construction phase. And also, I was quite amazed to see the extensive use of instrumentation to monitor the weather, the settlement, the expansion, contraction at the joints, and discharge at the various points, the groundwater pressure, and also it's quite interesting that there is a early warning system or the warning system installed at the dam. And one of the biggest challenge in implementation of such a project with the multiple dimension and multiple stakeholder is that there are a lot of issues. And he discussed the range of the problem in the contractual aspect of the project. Also, he suggested way forward to how to solve this problem. And these insights are really useful in future project as well. And the pertaining problems related to the building of dams in conservation areas, and also the technical challenge regarding the availability of the quality data in such project was highlighted in the presentation. So I quite agree with Mr. Nishal's remark that there are a lot of challenges which we face while doing such a large scale project in Nepal, mostly related to the data and the technical aspect. Also, moreover, the multiple agencies with their own interest across the various government department creates a conflict due to the in such projects. So there are various departments which have their own interests and they want to do things their own way. So his remarks on how to avoid such conflicting situation by making a joint operation was really a good one. Finally, he also had some remarks on the capacity building and maximizing the use of experts' time during the construction as well as the commissioning of such projects. So, since we are in a rapid phase of development of large infrastructure in Nepal, so it will be quite useful to learn from this project and then produce our own skilled manpower in the future, so that we can reduce the cost of those projects in overall. Also, uh, use this skilled manpower well within inside the Nepal. And one thing I would like to highlight is during the grouting presentation, he also uh, gave us insight into how academia in Nepal can be linked up with the real applied project. So I saw this during the construction. A master's thesis project was done in this grouting case. It was quite really amazing. I think the the person who did the master's thesis is also quite uh, right now in the presentation, if I am correct. And this was really interesting insight into how to link up the academia as well as the real world problems. So these were the summary of the projects. So I really appreciate on giving us quite wonderful presentation. Now I would move on with the panel discussion. Before that, I would like to introduce our remaining panelists. I have already introduced Mr. Naresh Swal and Mr. Kem Prasad Bhattrai, and Mr. Naresh Swal has introduced myself earlier. So I'll go on with introducing next panelist, who is Ravi Misra, a PhD student from IIT Dhanbad. He specialized in hydraulic engineering. He holds a bachelor's degree in civil engineering from Punjab Engineering College and master's in hydraulic engineering from IIT Roorkee. So where he researched piano keywords with the curvilinear keys. He also has worked on diverse research projects inside the Nepal funded by the World Bank, ADB, and focusing mainly on the irrigation design, hydraulic modeling. And one of his core competency is in computational fluid dynamics. He has a wide range of publication in national and international journals, and he brings valuable expertise in water resource management and hydraulic structure. We are delighted to have him on panel today. We welcome him here. So our next panelist is Mr. Pratyush Jha, who holds a master's degree in science from IIT Roorkee, and he is quite renowned bridge designer. He is a practicing earthquake structural engineering in Nepal. He has completed his master's of technology in structural dynamics from the Department of Earthquake Engineering. He was also a DAD scholar for research at Technical University of Munich during the year 2016 and 17. Presently, he leads consulting services and training related to the bridges and dynamic solutions. He is also active in research aiming to improve the resilience of structures subjected to multi-hazard environment, which is specific to Nepal at our organization IIHR. You can also see his article published in various national and national newspapers. And our next panelist is Mr. Rakesh Kumar Chaudhary. He is a doctoral researcher at Utah Water Research Laboratory at Utah State University. He holds a bachelor's degree in civil engineering from Pulsar campus, Tribhuvan University, and a master's degree in water resource engineering from IIT Roorkee. He has extensive experience in He has extensive experience in water-related projects across Nepal, along with the engagement in academia. He briefly worked as a lecturer at Dhap Dam campus, IOE, and also he's now serving as the CEO of IIHR. His research expertise spans from the scour, labyrinth, and piano keywords and channel hydraulics. Currently, his research focus on the irrigation in labyrinth and piano keywords. He also has authored on numerous publications on topics including the scour, piano keywords. We are delighted to have him today on the panel for the discussion. And lastly, I would like to introduce our final panelist, Mr. Ishwar Joshi, who is a PhD candidate at Utah State University. He specialized in flood hazard and flood risk research, and previously he also worked in uh, river morphology. With his extensive experience in water resource engineering, he has collaborated with professionals from China, Europe, and the USA. So he has fostered a global perspective in his work. His short-term focus lies in advancing the understanding of water behavior, while his long-term goal is to leverage this wholesome knowledge for the benefit of the communities and enhance the resilience to water-related challenges. So his expertise and passion drive his commitment to creating a meaningful and sustainable solution in water management. So we are delighted to have him as our panelist for today. So the discussion will go in this way, that I will ask all the panelists the question related to their specific field or relevance according to their expertise with regard to the topic presented by Mr. Nishchal. And at last, I also summarize the response from the panelist. So,
Kamal sir,
yes.
there are a few questions from the audience. I think first you start from the audience questions.
Yeah. Okay. So we have questions from Mr. Thakur Prasad Sharma. So his question is, the DV contract was as per the FIDC contract, where the dispute resolution is well stated. Despite it, the case has to go to the Supreme Court for its resolution. Can you elaborate more on this? So his question is related to that. If everything was already mentioned in the contract, where the dispute has to be resolved in what ways, why does the dispute has still to go into the Supreme Court? So, Mr. Nishchal, can you have your remarks on this question?
Okay. Thank you, Thakur sir. I'm happy, very much happy that you are here. Uh, uh, as I have already mentioned in my presentation, also there were several ad hoc decisions from ad hoc oversighting agencies and government of Nepal also, because we are having several amendment in the procurement regulation regarding this disputes. We have already formed a dispute adjudication board during the contract management period, contract implementation. This board has awarded the contractor's claim, but due to the decision from the Department of Water Resource and Irrigation, we appealed into High Court, and High Court also awarded in the favor of contractor, and arbitration also awarded in the favor of contractor. But the department is not ready to implement this decision because some ad hoc decisions were made from Ministry of Finance before claiming the budget, before proposing the budget for the payment against the dispute. We need to go at least Supreme Court. So based on that, that type of ad hoc decisions, department has decided to appeal in the High Court. Thank you, sir.
Okay, thank you for the answer. And for the next question, so you already mentioned in the previous slide, in the beginning of the slide, that the main objective of the project is to maintain the flow in the Bagmati River during the dry weather, mainly for the religious purpose as well as for maintaining the ecology of the river. And after the implementation of the project, so have you felt that this objective has been made? And what are the benefits? I think it's more like, what are the economical benefits from this purpose? Like, if you allow the discharge in the river to increase during the dry season, what are the economical benefit from this kind of decision, and does it justify the cost of the project? So this was the question asked by Mr. Mahata.
Okay. I think this type of project, the main concept of this project is to augment the river flow in the dry season, and that mean I mean the main objective is to improve the environmental condition. We are not focusing in economical perspective. Beside from that, as I have mentioned in my last slide, the impact of Dhap Dam on in terms of tourism and revenue also. And similarly, we are also starting we have also started water barter, and we have released water for the Melamsi water supply, Kathmandu Upateka Khanipani Limited. And simply you can see now we are having 1.42 million MCM water in Dhap Dam. If you multiply this amount with 10 rupees per meter cube, because the water tariff decided by the KUKL is 10 rupees per meter cube, I think. If you see this figure, we are having more almost 14 million 14 million, we can generate 14 million Nepali rupees by selling the water that has been stored in the Dhap Dam in this time.
Okay, next question is from Thakur Prasad Sharma again. So what was the initial contract period, and when completed, what is the time taken, and how many extensions were given to the contractors?
I think initial contract period was only 2 years, but due to delay in site position, because we are not able to get permission from the Ministry of Forest and Environment for the removal of the tree. So we need to extend the contract period. During the course of contract implementation, we faced two waves of COVID pandemic, and then we have extended the contract period. I think we have extended the contract period up to 28 February 2023. The main cause behind this delay was the site position and the COVID pandemic, and the supply chain was also interfered by this pandemic. Whatever the time available, that was available for us, I think that is more more reliable, and in comparison to international practice also.
Okay, also I had this in my mind, and Mr. Anuj has asked this question. So can you elaborate what kind of spillway is provided in the dam? And also, like, during the normal operation of the dam, you need to provide a minimum flow downstream in the river. So what is the ecological flow required and how it was achieved in the project, and how do you manage this?
Yeah, we have made open ungated spillway having chute and flip bucket in downstream, and capacity of spillway is 1.8 meter cube per second. And regarding ecological flow, because Dhap Dam is very small dam having catchment area only 0.85 square kilometer, whereas the catchment area of Nagmati Dam is around 13 square kilometer, and the catchment area for the if you consider the outlet in Gaurighat is 64 square kilometer. Comparing this figure, the contribution of Dhap Dam is very less. And initially, we have planned to release 40 LPS water continuously during the dry season, but later on, while discussing with different agencies and from Pashupati Vikas course, they proposed to release the water in major festivals, basically focusing on 9 major festivals during the dry season. So we have revisited our initial plan and make operation plan based on that. Nowadays, we released water in intermittent basis for the 9 major festivals, at least for the 14 days. And
Okay,
this, yeah,
yeah,
if
you can
we,
continue on. Yeah.
yeah, I want to add something. If we are proposing Nagmati Dam, and after construction of the Nagmati Dam, we will be able to release around 450 LPS release and 150 LPS ecological flow, and altogether 600 LPS throughout the dry season. Thank you.
So the next question was related to the management of the construction of concrete in slope and its finishing. I think you have sufficiently explained them in the presentation with different figures. Was nice figures. And then I'll move on to the next question. What kind of the software was used for the structural analysis of the CFRD dam? And what is the age of this reservoir? If there are issues with the sedimentation, then the reservoir capacity will be depleted over the years. And what is the planned age of this reservoir according to the design?
Yeah, see, the main design concept of the CFRD was is basically focused on the past experience and the best engineering practices. There is not any thumb rule, empirical formulas and models for the design of the CFRD. CFRD design concept is based on the code developed by iCode and iCode bulletins, and the different problem encountered in the different dam, and the resolution used to settle that problem. Based on that design, has been carried out, and this is the global practice also. And I think this is sufficient.
Yes, I think you have sufficiently answered all the questions related asked by the audience. In next phase, we will go on with our panel discussions.
Yeah, Kamalji, I remember. Regarding
Okay,
sedimentation,
okay.
since the reservoir lies totally in the forest area, we have also studied about the impact of sedimentation on reservoir in collaboration with the Institute of Engineering and Pulso campus. And the study shows that there is no significant impact of sediment on this reservoir. So, due to sedimentation, there is no significant effect in the life of the reservoir.
So I think we have already crossed our mark of the time limit, but since we had some problem related to the technical issues of the Zoom during our presentation, so we'll continue a little bit furthermore. and I like to ask panelists question one by one. The first panelist is Mr. Khem Prasad Bhattrai. For you, the question is, what do you think is the main technical pitfall experienced by hydraulic structure design in Nepal? And since you have already worked in the hydraulic design of different hydropowers, and what do you think are the key areas of improvement based on your experience? And what are your suggestions to a new hydraulic researcher for further enhancing the skill in this particular sector?
Thank you, Kamal sir, for this opportunity to be part of this discussion. I'd like to express my gratitude to Chhatkuli sir for his insightful presentation today. Regarding the question you have asked, one of the primary technical pitfalls that I feel is the lack of robust hydrological studies. Accurate estimation of high flood levels is crucial for ensuring the long-term safety of hydraulic structures. But usually in some projects in Nepal, unfortunately, we have seen that high flood levels are underestimated, which has caused devastating losses in the projects. This compromises the safety and durability of the structures. Also, the estimation of mean flows, which determines the economic returns from the project, is equally critical but often overlooked. Without accurate hydrological assessments, both safety and performance of these hydrological structures are at risk. To address these issues, I would emphasize the importance of conducting thorough and detailed hydrological studies before the design phase. Additionally, integrating modern numerical and physical modeling techniques can help us understand the hydraulic behavior of these structures. This is essential during the design phase and also for the post-construction performance evaluations. For the suggestions to hydraulic researchers, I would like to say that in addition to understanding the construction design process, hydraulic researchers should also focus on mastering modern tools such as CFD, which are like Flow 3D, Delft 3D, OpenForm, and hydrological modeling and remote sensing. These tools allow for more accurate predictions and improved designs. Also, researchers should actively participate in projects that bridges academic research and practical implementation that help to understand real-world constraints and field challenges. Thank you.
Thank you, Mr. Khem, for your insightful comments on how to achieve the perspective of new hydraulic engineer, as well as what are the challenges for a hydraulic engineer while designing such projects inside the Nepal. Next question I like to put forward to Mr. Ravi. So he has an expertise in hydraulic engineering. So I would like to ask him, what would you like to emphasize are the main problem with the hydraulic operation of dams like Dhap in monsoons or during the extreme weather condition? As you saw in cases like Melamji, you have the cloudburst activities, which are now getting common, and the extreme event are happening at more quite frequencies. And to what extent do you think the hydraulic modeling tools are available in the safe operation of this kind of dams? So we are waiting for your response.
Thank you, Kamal sir. And first, I would like to thank our speaker, Nishchal sir, for delivering such an informative and enriching talk on the Dhap Dam. Now, coming to your question, in my view, the primary hydraulic challenges faced by dams during extreme weather conditions include the impact due to sudden and intense inflows, as well as the impact due to sediments and the debris flow. As we all might know, that in such extreme events, it the extreme events may lead to rapid reservoir inflows, posing a risk of overtopping of spillway capacity if it is not adequate or poorly managed. Also, uh, the sediments loads which are coming in such events can clog the spillways, reduce their storage capacity, and increase the risk of upstream flooding. Furthermore, the floating debris carried by the flood water can damage the spillway gates and obstruct the water flow. Now, in many cases, what I have studied in the literature so far is that debris flow are overlooked while the design of such structures. And it would be beneficial for long-term maintenance and as well as the life of the structure if such debris impact could be also incorporated in the design process. Now, coming to the second part of the question regarding the numerical modeling tools and their role, I believe that numerical modeling tools play a crucial role during the design and also operation of dams. As Khemsar mentioned earlier about the computational fluid dynamic CFD models, for instance, such CFD models simulate reservoir behavior under various inflow scenarios, allowing engineers to predict risks and optimize the design. Such multi-scenario analysis ensure that spillways are capable of handling extreme inflow conditions under various scenarios. Additionally, numerical modeling tools may help to evaluate the seepage through rock fill and concrete joints in case of the concrete-faced rock-fill dams, such as Dhap Dam. This may help us identify potential weak points and mitigate the risk effectively. That would be from my side. Thank you.
Thank you, Mr. Ravi, for your comments and your answer to the questions. And next, I would like to move to our panelist, Mr. Pratyush. So he is a designer and consultant in multiple hydraulic engineering projects. And I think he has visited almost all of the districts in Nepal. So he has a good overview of how the hydraulic engineering projects are conducted well within the area of Nepal. So I would like to ask him, how would you rate the difficulty in formulating the plans for the project like Dhap in different other part of our country? And what would be the technical challenge in the field of implementing this kind of a project? And what can be the key areas of the improvements? Can we have the insight on these questions from you, Mr. Pratyush? So if I don't see Mr. Pratyush online, I would like to forward the next question to the next panelist, but I'll ask different question according to his expertise. So I'll move on with Mr. Rakesh. So Mr. Rakesh, you have extensive experience in design of the dam discharge structures, and also your master's thesis and the current PhD project is related to that. So what kind of risk assessment do you think are required for the project like Dhap Dam to include for the large event like flood? And what are the novel advances in new kind of the structures that can handle these discharge from the extreme events? I think the earlier question was already answered by Ravi. It would be more helpful if you give us insight into what kind of the novel structures do you think are applicable in such cases for the extreme event, where you can have a simplified structure as well as more reliable structure.
Thank you, Kamal sir and Nishchal sir for such nice presentation. I think that in the current scenario, we are facing the frequent floodings and intense intensity of the floods due to the climate change. I think that it will be better to increase the discharge capacity of the weir, that is which acts as the safety for the dams. So I think there are increasing rate of the introduction of the non-linear weirs. I think the labyrinth weir is a very common types of weir, which is now has been used in the being used in the USA and other countries. I think labyrinth weir is simply folded in plan view to increase the crest length of a given channel or spillway width. It is simply the triangular forms or triangular alternate cycle of the crest. It has a discharge capacity around, I think it is 200 to 300% compared to the higher than compared to the normal weirs. Similarly, we can use the piano keeper, which has 3 to 4 times higher discharge capacity than the normal weir. So I think labyrinth weir and as well as the piano keeper will be the best option for the dam safety. In case of the frequent floodings, I mean the intense flooding, increased discharge. I think it increases the discharge capacity also. And I think on PKW, I think Ravi did extensive lab works on the PKW, and it has now been you'll find that there recently in India there is a one project in which the PKW weir was constructed, and it is now functioning very well. It can pass maximum discharge at very low heads. So I think it will be better option for the labyrinth and piano keyboard types are the better option for the dam safety in sense of in sense of weir capacity. We can adopt this type of weir for the that we are planning to construct the Nagmati dams and other dams in cascades. So we can use this weir instead of the normal weir, which can enhance the capacity of the weir. Yeah, that's all.
Thank you, Mr. Rakesh, for your insights. And next, I will move on to our panelist, Mr. Ishwar. So he has worked extensively in the field of the river morphology and now working in the field of the flood risk management. So I would like to ask him question, how would you view the Dhap Dam project operation with regard to the river morphology changes and flooding changes due to the dam operation? And what would be the area of your concern and your ideas to tackle them?
Yeah, thank you, Kamal sir, uh, for the question, and thank you, Nishal sir, for a great presentation that covered design, in some aspect, design parameters, construction, and uh, other policy level challenges and others. Thank you very much for a great presentation. So, like regarding Dhap Dam, since my expertise is on river morphology and sediment transport, and I work closely with these and their impacts on flood risk. So if we see the operation of reservoir, like as Mr. Nishchal sir told that like we don't have like upstream sedimentation. So I'll I'll stick to that point because I do not have like experience or field visit opportunity at that site. So what kind of sedimentation exists there? So I'll stick to your point that there is no sedimentation challenges upstream of the dam because of dense forest and others. So I think in that regard, like the major challenge will be like surely the dam reservoir will bit scour during the like high flows. So you have additional head immediately downstream of the Dhap Dam, so that may cause a bit of local scar and then take the sediment downstream towards the lower areas or the downstream in the valley. So in terms of flood risk, so that scout sediment immediately downstream, how is it carried will have impact. And so how is it operated? So here it is crucial, and how new equilibrium is maintained, and also how the sediment front that occurs after scouring, immediate scouring, from the downstream toe of the dam that propagates will be really crucial, and how it is impacted by the operation of the dam. Will be challenging. Also, it's as we see that since the valley is very flat, so that front wind it is propagated downstream towards the channel in the river in the valley, so that may cause additional flood risk. So like if we have additional imagine if we say that we have additional sedimentation upstream of the reservoirs, like in the case it is not, which is highly unlikely, I'll say. In that case, like how that sediment is, since it's a dam project, so it will be stored. So how that upstream sedimentation is managed, especially will it be trucked or will it be carried downstream by river, or just excavated from the reservoir and taken to other side? So that will really impact the flood risk downstream and also the river morphology. Yeah, that's from my side. I think it was a great presentation from Mr. Nishchal sir, and it's like I see it's very useful for like both like undergraduate and graduate level students, and uh, I think it's kind of forms of framework, and also for the people who do construction work. That's a really great presentation. Yeah, thank you very much. Yeah.
So if we have Pratyush sir joining us again, then I would like to rephrase my questions, or if you have already heard the question, you can already start answering them. Mr. Pratyush sir?
Kamal sir, yes, I am available. So question
Okay.
was regarding, I forgot the question once. Question, please.
Okay, so I can repeat the question again. So as you are a designer and consultant in multiple hydraulic projects across the country. I think you have visited almost all districts of Nepal, and you know how to formulate the plans and projects. So how would you rate the difficulty in formulating plans for the project like Dhap in other part of the country? And what would be the technical challenge in the field of implementing this kind of the project? And what can be the key areas for the improvements? That was my question.
Okay, thank you, Kamal sir. First, I'd like to thank Nishchal sir for the very impressive presentation. He had included several key details of the project. So, coming to the question, I am not an expert on dam exactly. I have designed 2 dams till now, but not studied so much extensively in it. But still, I like to answer the question in a more general way. So, for me, doing projects in Nepal, I think the main challenge, technical challenge, is the availability of skilled manpower. And Mr. Sir has also highlighted the cost of importing of foreign experts. So, like that, I'd like to give an example of our university, my alma mater, Roorkee University. So earlier it was established as Thomson College of Engineering with main purpose to train officers, surveyors, engineers for construction of the Ganga Canal. So later that has transformed into a university and now IIT. And it has contributed not only to the project of the Ganga Canal, but later in nation development and development of science, as we know the Khosla curve and several other theories have been proposed by scientists and professors at IIT Roorkee. So I'd like to propose in Nepal that we can have similar institutions that can build capacity development of the people involved in dam construction. I don't think we exactly have any course in dam construction or such degrees. So that is one point I would like to highlight. And regarding Nepal, we have constructed this Dhap Dam. But in geographic, we have varied geography in Nepal. Mr. Sir said that this kind of dam can be made in alluvial soil as well as rock soil. But I'm very sure that the details of the construction and even the drawing, section drawing would be different for different kind of geology. So we can surely not copy paste the same Dhap Dam design to different places. So that highlights the need of more. And we are saying that it is seismically very sound, very safe, but it can only be studied through research, like how it will behave during different ground conditions like far field earthquake or near field earthquake. So those things, I think we need a institution and more like a university that can train people in the processes of the dam construction. So another thing, Nishchal sir said that the project was a design build. I have been involved in some design build projects, and I know how difficult it can be in managing design build projects in Nepal, especially when the contractor is already there and we have time pressures and pressure of different laws. So I guess Nishchal sir would have many sleepless nights studying the I-code guidelines and different technical documents. So if we have this kind of projects, I think first it will be better to go with item rate contracts, because design build has its own varied pressures. So that is one suggestion. And then I like to congratulate again the Dhap Dam construction team, the contractors, especially the ADB support, consultant, clients, manpower, who have led to successful completion of the dam. And the best thing about Dhap Dam is it is so close to the Kathmandu, where most of us are located, that we can go and study the dam. And not only study, as Nishchal sir said, there is a beautiful tourist location now in the dam where boating and different activities can be done. So it is the best place for us to go and learn more about the dam. So I'd like to encourage everyone to learn more. And regarding the environmental challenges, so that is another challenge that Mr. Sir has highlighted. I think I don't know how the loss of water in the river is managed in the Dhap Dam, but I have learned that they are dismantling several dams in the US and to restore the river back. So I would love to learn more about how the environmental aspects of the dam has been tackled in the Dhap Dam. So with this much, I'd like to conclude my remarks. Thank you.
Thank you, Mr. Pratyush sir, for your insightful comment into how to formally formalize any institution inside the Nepal which can really put forward or carry forward this kind of major construction work with the inbuilt expertise inside the Nepal, and also the major challenges regarding this kind of the project. So finally, I would like to ask the panelist for the first panelist. So he was also the first to host this webcast, Mr. Naresh Swal. So his main expertise lies in the multi-objective optimization and reservoir scheduling. His master's thesis and research work primarily were also related to that. And now he's also engaged in extensive work related to the environmental impacts. So I like to ask him, what are the main challenges faced by the project like Dhap Dam, where you have a multiple stakeholder and multiple objectives. You have to schedule the reservoir according to those requirements. And what do you think are the missing key pieces in current operational plan of the Dhap Dam? And what would be your suggestion or ideas for the further studies to strengthen the operation of the dam, considering all the objectives? Mr. Naresh?
Thank you, Kamal, and thank you, Mr. Nishchal sir, for his enlightening presentation. So, to talk about global scenario, dams and reservoir are built for flood control, hydroelectricity, and water supply. However, the Dhap Dam case is unique, as its purpose is to improve water quality and to ensure the water security in the Bagmati River basin, and to provide safe drinkable water to Kathmandu Valley in near future. So, given it relies on rainwater, the Dhap Dam faced significant challenges from climate change, such as frequent drought and heavy rainfall. So I think the dam should operate in such a way that it balance flood control during intense rain, and it ensure the sufficient water storage to sustain the flow in dry periods. So to address this kind of challenges, I think the advanced forecasting tools can be incorporated into dam operation, so that we can anticipate future scenario such as drought and intense rainfall, and we can adopt this kind of management strategy accordingly. So in general, there will always be trade-off between the objective of reservoir. So we need to develop optimal models and use it accordingly to meet the priority of the reservoir. So in this Dhap Dam case, the only thing we need to consider is we can incorporate the forecasting model so that we can balance the flow control during intense rain and ensure the sufficient water storage to sustain the flow in the dry periods. So I would like to say this much for this question. Thank you.
Thank you, Mr. Thank you, Mr. Naresh, for your insights. Now, I would like to formally keep a concluding remark. Before that, I also am going to read some remarks from our participants. So, one of the participant has implemented that we are also in quite near future going to construct Nagmati Dam, which also has similar nature but in difficult topography with greater dam height. And we are investing a lot in this kind of the project inside the Kathmandu Valley, which is a major center of economics as well as the centralized power structure in Nepal. And if similar investment were made in other part of the countries, such as Mahabharat, then we could have the better utility as well as better flood control in those regions. So yeah, this is a valid question. So we need to invest a lot in the other multiple projects that are located well outside the Kathmandu valleys, mostly in the center areas with agriculture, where we can have better utilization or the economical benefit other than tourism, because the economical benefit from the agriculture of in cases of countries like Nepal is higher in comparison to tourism in the localized urban center. So yeah, and so another question is from Mr. Pratyush to everyone. Yeah, another crazy question. Can the Dhap Dam and Melamchi water supply have any relation to severe flooding in Kathmandu Valley this year? So yeah, this is one kind of the valid question. So in case of the extreme rainfall event in the upper region of the Dhap Dam, surely they will release a lot of water from the spillways. And since this would be a controlled release, then you will have a lot of water flowing there. And also from the Melamchi, if the water is not used for the general purpose, it will end up in the drainage system, and that would already overwhelm the system, which we have seen that the system has already less carrying capacity of the discharge in the monsoon season. Yeah, this is a valid question. So thank you everyone for having such a insightful discussion, and thanks to our expert presenter in the issue, and his insights are really valuable for all kind of the audience, from related to the academia as well as the construction management as well as the government official. Then I would like to proceed to our closing session. So on behalf of IIHR, we want to express our heartfelt gratitude to everyone who participated in this webcast despite the time constraint and the early morning session. I see a lot of participant and enthusiasm from the participants. And special thank to Mr. Chhatkuli for his enlightening presentation on lesson learned from the Dhap Dam, the first kind of the concrete phase Rockfilled Dam in Nepal. Your expertise and insights were really, really invaluable, and we thank you again for that. And special thanks to our panelists with their insight into their expertise and enriching the discussion. So your contribution greatly enhanced the depth of the conversation, especially with regard to your expertise. And to our participants, so we got really good questions from the participants, had a really great engagement and attention throughout the webcast. And I call this event a success because we have the good participant from, we have engagement from the audience, as well as also insightful comments from the panelists. And there might be some shortcomings during this webcast. As you saw earlier, we had some technical difficulties with the Zoom. We'll try to improve that in future. And if you have any comments regarding this webcast, you can, we will shortly distribute you the website link to have your comments on this webcast session. We'll try to improve this webcast session and make it more lively discussion in future day. If you want more technical discussion or like the general discussion, then we'll have a different kind of the session for this kind of the webcast. So your involvement made this webcast truly meaningful and insightful. Thank you for attending all. Now I would like to hand over the floor to Mr. Nareshwal again and close this session. Thank you. Thank you all.
So it's getting late, I think. So I would just like to express special thank to Mr. Chhatkuli and to all our participants. So we'll be have different webinar series. So we will be in touch. So we will send you email and we will post our upcoming webinar. So I hope you all will join our upcoming webinars. And thank you for all. This much for today.
Thank you, sir.
Thank you. Thank you. I ask you to
Thank you.
leave the Zoom, please. See you.
Thank you so much.
Thank you, Nishchal sir.
Thank you, Rakesh sir.
यो चाहिँ एकदम डिटेलमा सर सानो सानो माइन्युट डिटेलहरु समात्नु भएको रहेछ हैन धेरै राम्रो लाग्यो ग्राउटिङको त मलाई एकदम अनसर्टेन्टी लाग्थ्यो ग्राउटिङ अब जति जान्छ त्यति हाल्ने हो कि जस्तो लाग्थ्यो तर